Okay, so tell me what your equation was.
Negative 12x squared.
No, tell me what it was from the beginning.
3 minus 4x times 32 plus 3x.
Okay, and your logic was that we started out selling 50 books, but every time we raised our price, we were going to lose 4 sales. So X is the number of price increases. That's the key right there. If you know what X stands for, then you can answer any question that you're asked. So X is the number of times I'm going to raise my price. Okay? So you FOILed all that out. You came up with an equation. You did negative b over 2a because the problem had to do with maximizing. And when you did negative b over 2a, what did you get for your X value?
Negative 11
Should have been 11. Are you positive 11 over 12? Because it's negative b over 2a. So if we FOIL this out, we get an equation. When we do negative b over 2a, it comes out to be 11 twelfths. Okay? So that's 11 twelfths price increases. All right, so the question says, what price should I charge? Well, what price am I charging right now? $32. So I'm going to add to that 11 twelfths increases, and every increase is worth $3. So that's the price that I should charge. Round it off to the nearest cent. All right. Who else? Ellie? You don't know what? What did you not know? Okay. So what framework did you set up for an equation? Y equals x minus 2 squared plus 4. Did you have a squared on there? Okay. So that has a vertex at 2, 4. Notice I got tricky. I said the word maximum. Isn't a maximum a vertex when we're talking about a quadratic? Yeah. So my vertex is at 2, 4. Okay. And the other point is 8, negative 1. So y equal, or 8, negative 1. So negative 1 equals n times 8 minus 2 squared plus 4. So negative 1 equals n times 36. Subtract 4. Divide by 36. That's your coefficient. Okay? All right, so put that away. Now what I want you all to do is get out a half a sheet of notebook paper. So why don't one of you get it out and break it in half and share it with your neighbor. Let's be friendly here. So we're going to get out a half a sheet of notebook paper. Share with your friend. Rip it in half. You guys are all going to have your own sheet of paper. Okay, so we all got a half a sheet of paper. Okay, so I'm going to everybody's got to be fully masked for this activity, right? I want everybody's mouth and nose completely covered up. All right, I'm going to put a problem on the board. And then I'm going to give you a minute, maybe 2 minutes, to take a stab at it. Rory, no iPad necessary. we're gonna take a couple minutes for you to take a stab at it individually. And then you're gonna lean across the aisle, not breathing on each other, maintaining distance if possible. And you're gonna consult with one another, okay? And I'll give you about a minute to do that. And then you're gonna consult the other way. So you two in the middle will go, and then the outside. So second time around, middle two, consult, and you'll have to get up and move over there. All right, got it? We'll do another minute there. And then hopefully, when we're done with all that consulting, we will have the right answer. Okay? We're short some people over there, so you two just consult. All right? Bailey will come over and consult with Roy. Got it? All right, so here's your problem. We're only going to take a couple minutes. Unfortunately, you guys don't get to consult, but you can try to figure it out. Ready? No notes, no iPads, no calculators, no nothing except our brilliant minds. All right, and here's our problem. I wrote it down. I want you, based on what we talked about yesterday, I want you to sketch this polynomial. So just like we did yesterday, I want you to sketch that thing. All right, so get started. Think about what we did yesterday. What? No, this is it. It's one problem. You're going to get as far as you can on your own, and then you're going to work with your partner. You guys can talk to each other, but you got to do it quietly because they're all listening. All right, let's partner up. person across the aisle that way.
Alright, read.
There, guys, don't breathe on each other. Side by side.
Spoilers, that's exactly it. I caught that lady. But only, you only put it, you only put it in there when it's like if it's negative 2 feet, right? You only put it in the middle thing. Oh yeah. No, yeah, you're right. We wouldn't put an origin there because you know X on the outside. So you have like 3 and then 4 top, 1 there. Okay, so since it's a negative, you start one up and down. So
It goes through if it's like double.
yeah, I didn't know that was going to start because of the taking out the negative too. Yeah, I caught that one. That was good. Because I was like,
It bounces off.
because I was only thinking about taking out the actual with it. So I was like,
And then if it's Q, that's when you
dude,
like.
somehow I started drilling physics. Yeah.
Like, I
The guy next to me taught me how to do it. And I was like, oh, this is easy. It's easy just plugging in for the equation. Yeah, especially when you graphs. Oh, I'm gonna go to after school. Or I'll just look on the answer key and figure it out. Yeah. Alright, we got it.
You figured it out? Now we're gonna group one more time. Unless you put your name on it, turn it in if you want. Whenever you think you got it,
I'm a group
put your
one
name
more
on it
time.
and turn it in.
The more people that have it correct, the better.
No.
No, we're chill.
Did you get Josh?
You ended down. You start up on the left.
Yeah, because it starts negative.
And on the outside.
Oh.
Right?
No, that's 1, 2, 3. That's 3. That's 3. That's odd. So odd starts down.
But it starts negative.
But the negative doesn't matter. It's just the exponents.
Oh, really?
Yeah.
So we got the same thing, I just did the wrong way. I feel like the negative
No,
has
but the negative doesn't have to do it. I don't think so. Can we ask
Does
questions?
this negative have anything to do with anything?
I can't.
Oh! I feel like it does.
I don't think it does. I think it's just the exponents. Start down.
Should I just leave it and see which one of us is right?
How many points is this worth?
Oh, she's worth like actual points?
It's like a.
But
It's like a pop
I know,
quiz.
I want to go with my instinct, but it's also like,
It's like a
what
pop
if I'm
quiz.
wrong?
Well,
I think what
sun
it
will
is.
come up tomorrow if you're.
Yeah, but
I
like
think
the
what it is.
math
Caroline, I think if it's a negative 2x, then it.
Okay, that's fair.
Yeah.
But like also the negative's still there.
Well, but it doesn't have an exponent, or it doesn't have a x on it. So
I'm
there's
just
no-
saying, like, if it's negative, the negative's still
Or
there.
you
Because
have
look,
about
this
another
factors
negative.
into
but
this.
you're counting the exponents though.
Yeah, but
1,
like, it
2,
would be
3.
like,
It doesn't
I'm
factor
leaving
into
it.
Okay, alright, you leave it. You leave it.
You're done.
Yeah, I'm gonna.
You're gonna call it.
Want me to rip it? One card. Same thing. Same thing.
He did what I did.
No,
Yeah, okay,
no,
when he
no.
started with my equation.
No, Michael did what they did.
Michael did what we did, and I think we're right.
Looks like Michael started to do that something else.
There we go. There we go. Right on.
All right, time's about up. So let's see.
Hey, what did you do? Roy, what'd you do?
Names on the paper.
You just know the way.
But the negative doesn't have an exponent on it.
Yeah,
Or
but
an
you
X.
factor the 2 through, and then the X becomes negative.
But there is no 2. You don't factor the 2 through.
Like, distribute
Oh.
it.
That's the direction. That's the direction of the arrow.
Yes.
So
No, listen. The direction's the exponents. It's the odd or even
I know.
exponent.
Yeah, no, I know. That's how you like show the bounce. If the bounce is off or not, right?
I know, I think we're
There's
still
no-
good. I think we're still good. I think we're still good.
No.
There are no exponents. So it's going through all of the points.
Yeah.
Right. But it's
But
starting
since there's
up.
three
No,
exponents,
it's starting going
it
down
starts
and
down, ends up.
Yeah, on the same time.
Did you start down and end up?
I started up going down and
No,
ended going down.
no, you're wrong. You're wrong.
No, because it started out as a negative 2 squared. Right? And then the 2 squared plus 8.
But isn't it just the
No,
exponents?
so we took out negative 2.
No, I know we did, but
And then it's x squared minus 4.
maybe we did.
No, we're fine. I think we're fine.
Oh, are we good?
Yeah,
Oh, yeah.
All right, guys, I need you to send it in to me real quick. All right, I'm gonna go over it.
We have that law.
Take the L. Take.
Already done that?
It's wrong too.
No, we got the same thing.
Exactly. So we got it right, then he gets it wrong.
No,
Sorry.
no. I hope you guys get it wrong.
Guys, have you sent me your quiz?
What did you say?
Okay, I need all of you to send me a picture of what you worked on, because we're gonna go over it.
I hope.
All right, while we are, waiting to get those pictures, we're gonna go over this, don't panic.
Yes.
We'll do this exact problem in a couple of minutes, I'm gonna leave it up there. But first, let's get our notes out and let's continue, because we've been living in a state of suspense from those two problems that we skipped yesterday. So, number 3, we're on page 6 of our notes, right where we left off. We're gonna come back and get those. But first, we got a couple more things to do, or one more thing to do. Number 3 says, find the remainder in 2 ways. Now, what I don't want you to think is synthetic division and long division, because those are 2 different ways, but they're both just division. So one way to find the remainder would be to divide. So whether you want to do it synthetically or long division, that's up to you. One way to find the remainder is to divide. I'm going to do it synthetically. What will go in the box for problem number 3? -1. And then I have 1, 5, -8, 3. So I drop my 1 straight down. All right, I don't know. How does that look? Does that look okay to everybody?
Yeah.
So the question was, find the remainder, so the remainder is 15, right? So if the question were, is this a factor? Is x plus 1 a factor? The answer would be no, because I got a remainder. Now, I want to show you something else, because depending on the size of the problem, division may be inconvenient. Here's what I mean. What if you had to find the remainder when x to the 203rd minus 5x to the 4th plus 9x minus 8 is divided by x plus 1? That would be inconvenient to divide. Because why? There's a bunch of zeros, right? It's going to take a lot of space. So there is another way. If all you want is the remainder, if all you want to know is something a factor, that means I just want to know what the remainder is. There's another way to do it. So the other way to do it in problem number 3, if your function is this, which is what it was, instead of doing the division, pretend like that is a function and evaluate it at the same number that you would have put in the box to divide it. So in other words, just plug -1 into the equation. So look what happens if I put in -1. I get -1 plus 5 plus 8 plus 3. What do you get when you add all that up? 4, 12, 3, 15. What do you get? You get the remainder. So if you don't want to do the division for whatever reason, you can always just plug in the same number you would have divided by, and that will give you the remainder. So if I had to do this problem, if I had to find the remainder here, now not the quotient, this isn't gonna give me the quotient. If I want the quotient, I have to divide. If all I want is the remainder, I'm just gonna plug in -1. And then I'll have my remainder. Work that out, and I've got my remainder. Okay? All right. So now, boys, have you all sent me your quiz?
Yes.
I got, wait, no, I don't. Yeah, I got 2 of you. George, where's your quiz? Can't hear you, George. And I don't have your quiz.
I sent it probably like 3 minutes ago.
I have Katie's and Declan's. All right, so let's go ahead and do the quiz question, and then we're gonna go back to
Something wrong. That's what we're doing.
F and G. All right, so here we go. What was your thought, all of you, when you looked at this and you said, oh, we have to graph this? Did you think about factoring it? You did. And when you factored it, I hope you grouped it, because it does group. So you pulled a -2x squared. Maybe, I don't know what you did, but that would be what I would do. I'd pull out a -2x squared. And that would leave me with x minus 3. And then you pulled out an 8, and that would leave you with x minus 3. So things are looking good. So we have x minus 3, and then -2x squared plus 8. Now, that actually, you can pull a -2 out of that, and it leaves you with x squared minus 4. Right here, I just factored this part first. And that is the difference of squares. Okay? All right, so now you're ready to graph it. It's all completely factored. So hopefully you put some x-intercepts on your curve at -2 and 2 and 3. So far, so good? All right. And then hopefully you looked at the original problem or at the number of x's you have, which is 3x cubed. And you remember that x cubes any odd power is going to have this behavior. It's going to start down here and end up here, right? Unless you put a negative in front of it. When you put a negative in front of it, what does it do? It does the opposite. So it's going to start up here and end down. Okay? Oh, Miss Ford, you're so mean. Come on. We learned about negatives before. Right? We can't forget about what negatives do. If I put a negative in front of an x squared, wouldn't you turn it upside down? Same thing. Same thing. Okay? How many got that right? How many had it right except you had it upside down? Everybody else? Alright, so everybody found the zeros, which is perfect. Okay, now it's time. What you've been waiting for. Go back to 2.3, F and G.
Okay. No, you're
So we're back to the 2 problems that we skipped because we weren't really prepared to factor them. Because the quiz question and everything up to this point that we've had to factor, we've been able to do it by grouping. which is great. If something groups, that's easiest. Always do that. But looking at these numbers, I mean, you're not going to be able to group that. Everybody sees that, right? You're just not going to be able to group this. So we need the factors, though. So that means numbers that we can divide in and have no remainder. So we're just going to start guessing. Now, if I'm you, I'm thinking, Mrs. Ford, there are a lot of numbers that I could be guessing. This could take a very long time, and you're right. So there's a way to narrow down the possibilities. It's still going to involve guessing. Some of you are going to guess right off the bat. Some of you it's going to take 3 or 4 times. But I can narrow down the possibilities. So instead of having to choose from infinite numbers, I can narrow it down. The possible rational roots, which I will always refer to as my PRRs, my possible rational roots. These are the numbers that when you have to start guessing, these are the numbers that you're going to guess. They are factors of the constant over factors of the leading coefficient. So for our problem, it's going to be factors of 55, which there aren't that many. The factors of 55 are plus or minus 1, 5, 11, and 55. That's it. Over the factors of the leading coefficient, which is 1. So instead of having infinitely many numbers to guess, there are 8. You're going to guess 1, 5, 11, and 55, and then -1, -5, -11, and -55. Guess them in any order you want. Personally, I always like to start with 1 because it's so easy. So I'm going to go ahead, take my problem, and I'm going to go ahead and I'm going to guess 1 because 1's in my list. Don't guess 2 or 3 or 4. Those aren't in your list. They will not work. I'm going to guess 1. Sometimes math is messy, folks. Sometimes you just have to guess. Oh my golly. What does that mean? It divided in and left a remainder of 0. So what does that mean? That means one of my factors is x minus 1. Remember, to graph this, I had to factor it to get my x-intercepts. Now I know there's 1 at 1. Now here's the good news. What's this? X squared minus 6x minus 55. Well, wait a minute. That's a quadratic. Can I just factor that? How does that factor? 11 and 5. So x minus 11, x plus 5. Is that right?
Yep.
Which means my dots are at -5 and positive 11. Remember, we're sketching this. Now, does this one have a negative out in front? No. So this one's going to be sketched just like a regular. And there you go, you're done. You guys may have done this last year. Anybody remember something called P's over Q's? Okay, this is P, this is Q. Your possible rational roots, that's your P's over Q's. All right, let's try the next one. That's not hard at all. That's just easy. and fun. All right, so I look at problem G. There is absolutely no way it's going to group. So I'm going to list my PRRs. There's a bunch of them this time. Factors of 96. So 1 and 96, 2 and 48, 3 and 32, 4 and 24, yeah, 5, no, 6 and 16, and 8 and 12, 9, 10, okay, that's it. So there's a bunch of them. When there's that many, it really doesn't help so much to have them. It really helped in that other problem. It doesn't help so much because there's still a time. But let's say you tried 1, 2, 3, 4, and none of them worked. You would skip 5 and go to 6, right? I mean, that's what your PRs do. They take the possibilities. All right, well, what do you want to guess this time? You got to guess one. What do you want to guess? 4. 4? All right, let's see if you're a good guesser. I don't think so. Right? What has to happen? I got to get a...
Negative 96.
yeah, and I'm not going to get that, so, yeah. So 4, no, that didn't work so well.
24.
You can try 24. I never try that big. I always stick small, because usually something small is going to work. What'd you say? Negative 1? I don't think negative 1's going to work. 3? And here's why I don't think negative 1's going to work. Negative 1's going to make that a positive 44. And 44 and 96 aren't heading towards 0. So I like the idea maybe 3. Let's try 3. We'll do 2 next. Let's see if 8 works. Oh, wait a second. Wait a second, wait a second. Did 8 work?
Yes.
Is that just wishful thinking on my part, or did that really work? I think that really worked. So one of our factors is x minus 8. And we can get the other ones right here, because that's x squared plus 4x minus 12, which is going to be x plus 6 minus 2. By the way, what are we going to do if that doesn't factor?
Quadratic.
Quadratic formula, sure. As long as it's a quadratic, as long as you got an x squared, you can solve it no matter what. This one does factor, so then I can graph it, right? So I got 1 at 8, negative 6, 2, regular old cube. So there we go. Easy peasy. Right? So that takes care of those 2. Now let's go back to page 6 and pick up where we left off. Find all of the zeros exact. Now, that means we're not using our calculator. We're not having rounded off answers. We're doing exactly what we just did. So this isn't anything different than what you just did. So 2x cubed minus 3x squared minus 4x plus 6, right? What are my PRRs, my P's over Q's, my possible rational roots?
1 and 6.
Well, we got plus or minus 1 and 6, 2 and 3, so 1, 2, 3, and 6 are factors of 6, but this time it's over 2 and 1. Now, what does that mean? What difference does that make? Well, remember, your possibilities will be each of these over each of these. So obviously 1, 2, 3, 6 over 1 is just 1, 2, 3, 6. But 1, 2, 3, 6 over 2 gives you 1/2 and 3/2 as additional possibilities. Now you guys obviously live dangerously. You want to try things like 24 and 8 and big numbers. Go for it. Go ahead and try your fractions, because sometimes the fractions work. This old lady is always going to stick with 1, 2, 3. I'm going to stick with the basics. But those other numbers will work. So feel free to use them if you want. So let's take a minute, find one. On your own, find a root of this. We aren't graphing, we're just finding our x-intercepts. We're finding the x values that we would plot on the number, or on the x-axis. Find one yet? Oh shoot, I hope I haven't made a mistake. Nobody's found one yet? Oh, I think I found one. I think 3/2 works. Double check my arithmetic. Okay. So one of my roots is 3/2. Gotta be patient. Yes, a lot of numbers there. What's that down here?
Quadratic.
Well, it's 2x squared minus 4. Right? So let's see, if I want to find the zeros of that, I could do the quadratic formula, but it might be easier to just add 4, divide by 2, and take the square root. Wait a minute. Didn't I tell you that all the possible answers were here? What's this stand for? What's that first star stand for? These are the possible rational roots. So these are all the possible rational numbers. These are irrational. And the only way you're gonna find those is from solving the quadratic. Okay? Your calculator will give you the decimal approximations, but the only way to get them exactly is to solve the quadratic like we did. All right, perseverance, perseverance, here we go. Look, what about B? Let's try B. If you find a root, would you shout it out? I think -3 works. Anybody else try that? Does that work? Oh, what, Rory, do I have a mistake?
No, I was just wondering, sorry, how do you get the 2 and the 1 in the denominator?
Here,
Yeah.
because the PRRs are factors of the constant over factors of the leading coefficient. So the leading coefficient was 2,
Okay.
and the factors of 2 are 2 and 1. Now this problem, I didn't write down the problem, but the factors of the leading coefficient is just 1. So technically this is over 1, but we don't need to write that, right? So I guessed around, I picked numbers out of my list, and I got one. So what's the next step? My job is to find all the zeros. So what do I do now that I know one of them is -3? I take what's left, which is x squared minus 2x minus 2. And that does not factor, so I'm going to use my quadratic formula. You could also complete the square if you wanted to. -b plus or minus the square root of b squared minus 4ac all over 2a. What's under there? 4 plus 8, 12. And this is one of those that's got the triangle of cancellation. So your other 2 roots are 1 plus or minus √3. We can't forget our quadratic formula and all that stuff we learned before. It's still all important. We still have to use it. How many answers did I ultimately come up with? 3. That is exactly what should happen, because what's the degree of the equation? 3. And the fundamental theorem, well, corollary to the fundamental theorem of algebra says if you got a degree 3, you're going to have 3 solutions. Okay. All right, oh my. Look at the next one. It's big. We've got it. We can do it. What are your PRRs? What are our possibilities this time?
1, 2, 4, and 8.
1, 2, 4, and 8. Not a very big list. Right? So, I don't know. What do you want to try? 1? I like to try 1. I don't think it's going to work, but it might surprise us. No, it's not going to work. There are 2.
2 does not work.
2 does not work. How about -2? No. Unless I made a mistake.
It's 4.
sure does work. So the directions say find all the zeros. Okay, we're gonna find all the zeros. So one of our zeros is 4. Now, look at what we've got left over now. This is a little bit different than it was before. What's left here?
X to the third.
X to the third plus x squared minus 2x minus 2. Now, could we guess again? We could. If you're really paying attention though, this actually groups. So always feel free to group if it's groupable. That will usually be faster, but you certainly could guess if you wanted. If I factor this by grouping, shoot, I should have tried -1, shouldn't I? Because one of my roots is going to be -1. And what are the two that are going to come out of this? Plus or minus square root of 2? So I tried 1, but I didn't try -1, and I should have. Because that turned out. Getting the hang of it? I think there's a couple more. Oh no, there's something new. Numbers, so we're good on this? When you have a big polynomial that you need to find the roots of or factor it, you're just gonna guess. As soon as you find one that gives you 0, then whatever is left, you gotta start working on that. So if it's a big one, you have to either guess again or factor by grouping. If it's a quadratic, you can just factor it or use the quadratic formula. Now, when you are just randomly guessing numbers, sometimes it helps to know whether you should be guessing numbers bigger than or less than the one that you just tried. Yeah, right now. Yeah. Yeah. Jessica, would you grab your stuff and come out? There's somebody out here in the hall to see you. Grab your stuff and come on out. Thank you. Okay. This is all on video, so you can catch it, Jessica, because I know you probably won't sleep tonight unless you know how to find an upper bound. All right? So here we go. To find out if 3 is an upper bound. Now, what that would mean to me is, if 3 is an upper bound, then as I guess, I will not guess numbers bigger than 3. So if my list is like 3 and 6 and 12 and 24 and like all those big numbers, if you determine 3 is an upper bound, you're done. Now, with numbers bigger than 3. Now, here's how you do it. Divide 3 in. All right, so here we go. Hopefully I divided right. Now, I didn't get 0. But I didn't expect to hit 0 because I wasn't checking for a root. I'm checking to see if this is an upper bound. What do you notice about all the numbers down here? They're all the same. They're all positive, right? Now what that means is, if you pick any number bigger than 3, you will not ever get 0. Because all these are just going to keep getting bigger and bigger and bigger. They're never going to cancel out and give you 0. So to tell if you have an upper bound, if all of your numbers are positive, you have an upper bound. You're done. Don't pick a number bigger than 3. Pick 2 or 1 or something, -5. Don't pick a number bigger than 3. Now, lower bound works the same way. Go ahead and do the division. We're checking to see if -4 is a lower bound. So I'm going to go ahead and do the division. But this time I want you to notice what happens. I don't know what that is. Okay. I don't know what it is. And it doesn't matter to me. All that matters is check out what's happening in this bottom row now. What are those numbers doing now? They're not all positive. What are they doing? They're alternating. When your quotient alternates signs, plus minus plus minus, or minus plus minus plus, when you alternate signs, you have a lower bound. Okay? Now, if you divide and you get something like this, that number is not upper or lower. Because to be upper, you can't have a negative in there like that. And if it were going to be a lower bound, if that one's negative, that one would have to be negative. So not everything you divide is going to be one or the other. But that's how you know. This would be an upper bound. That's what the quotient looks like. And this would be a lower bound.
Will they ever all be negative?
They could,
But that representative?
probably not. All right, you good on that? All right, I think that's enough for one day. We've absolutely blown your minds. So I don't see it tomorrow, but on Friday I will. And on Friday, you are going to have 2 homeworks due, 2-3 and 2-4. Some of you have already done 2-3 because it was easy.